Take. That's cool. But it's around 6:30, so that's where we go start. Distract us from 1:30. So I'm Chris Marinos, and today I'm going to be talking about getting your functional on with F#. So usually when I give talks on F#, it's to like an intro, like intro to F# or intro to functional programming to a C# audience. So I know this is an F# user group. I'm kind of curious, what's the makeup of people here? Like, how many people consider themselves F# developers, comfortable with F#? Okay, so few people. What about functional programming in general? Okay, and then the rest of everybody else, C# mostly. Okay, .NET. Other functional languages or other dynamic languages and stuff like that. Okay, so pretty mixed group. So I think this I'll cover some things along the way that should be pretty broad ranging and applicable to everybody. It just occurred to me before I got up here, I'm going to be talking a lot about Silverlight, WPF, MVVM applications. How many people are familiar with model view model? Okay, so a good amount of you. And okay, all right, that just gives me a little bit of a feeler for what's out there, so I know how to kind of structure things. All right, cool. So the real meat of this presentation, unlike a lot of functional programming talks, it's not going to be about academic problems. It's not going to be about niche applications. This presentation is really about how F# can help you solve practical problems. So we're going to look at a sample application, talking to a REST feed and built in WPF, from the ground up in F#. So there's a few different ways to go about it, and I'll show you one approach to kind of structuring applications here. So I think I'll skip over this next section, which is just kind of an intro to F#. Does anybody want me to cover like the intro to F# stuff? It's just like 2 slides anyway. All right, cool. All right, so the first thing I want to take a look at is how an F# application is structured. And in particular, we're going to be looking at more GUI-focused applications. So a lot of times, if you're into functional programming, you might structure things on a more functional way. And there's obviously a lot of different ways to structure applications in F#, just like there is in C#, VB, or any other programming language. So there's a lot of different approaches. This is one approach, and obviously, there's different ways to go about it. It's going to tend to be a little bit more on the object-oriented side, but blending in aspects of functional programming as well. I think it's a good overall balance, but I'll discuss a couple other ways that you can go about it. So with that in mind, let's dig into some code here. Okay. So I'll go ahead and run the application. Hopefully the Wi-Fi is working here, just to give you guys an overall view of it. So this application that we're going to be talking about it's going to be a video game browsing application. So you have different platforms up here, and you can click on a platform, and it'll go out to this Games Radar REST service. And right now it's doing it all synchronously, and it's going to kind of spin here for a little while, lock up the GUI while it does this, and it should come back in a second with a list of games. There it goes. So you see it like just a little, you can kind of scroll up and down. It's got a list of it, the genre, platform, just real kind of a basic example of a pretty simple GUI application in F#. So let's go back to the actual question at hand here. What does this application look like? How is it structured? And on first glance, I don't know if you can read over there in the Solution Explorer, but basically it looks a lot like a model view MVVM application in C# or any other language that you want to do. It has an app XAML, main window, and some other user control XAML, and so the overall structure is pretty similar. And if we dive in a little bit here, you'll see we'll open up the main window. And you'll see main window has kind of the overall feel of the application. Now, since this is an F# group, I'll dive into a little bit of the specifics here. In general, there's a couple different approaches you can go for building these kinds of applications. There's the polyglot approach, which takes C# and F# and kind of use them together. So you have your views in C# and your view models and models in F#. So it's all the real messy stuff is in F#, but you use C# because it has better designer support and it's built to work with WPF and Silverlight. I tend to prefer that approach just because, as you'll see, though, there's some limitations with the F# approach that you can work around, but I don't find it to be as much benefit. In this example, since it's an F# group, we'll be doing everything in F#, and I'll show you the workarounds and how that works. So one thing is, I'm getting an error here right now. I'm using a viewModel locator pattern, which I'll explain a little bit more in a second. But basically, I'm getting a compile error down here. It can't find this static resource because it's defined by app_XAML. So if you want to use app_XAML at design time, obviously at runtime, you saw it work. But if you want to use an app_XAML at design time, you have to go in here and do a quick little hack to get the designer working. So you have to change it to application definition in the build action, and then close out the designer and come back in. And now you see I have some design time data here. So I've spiked this out at design time with some fake game objects inside my view model. And I'll show you that in a second. But basically, once you kind of have this in place, it works a lot like the C# GUI designer would. So if you go in here and I change the title of the window, I need some extra text here. You'll see it updates in real time up at the top. So I can kind of play around with my UI and design it. You can do this. You can use blend and everything too. There's a couple of quirks to using F# with blend. You basically, if you don't have Visual Studio installed, blend doesn't ship with F#, so you need to go out and install it. If you're working with designers that don't have Visual Studio, we have blend. But other than that, it's actually not too bad. So you can get the basics, but you'll see there's little workarounds like this that make it kind of challenging to use an all F# approach. But if you want to, you can, like I'm doing here. You'll also see I can do pretty much whatever I want, whatever I could in C#. I have a static resource here, this viewModel locator, which is defined by app_XAML over here. So this viewModel locator is defined here. And what that guy does is, if I go into my game browser resolver, it's using an IOC container, just like I would in C#. Using Ninject, I'm basically creating a new IOC container and creating a few bindings for my web service and my view models, and then this is what gets called by the rest of my application. When I bind my XAML here, you'll see I have a binding for main window view model, and what it's going to do here is it's going to pass main window view model to this guy, ask it to resolve it, so it's going to look down the active assembly and try to find a matching type for that, and if it finds the class, it's going to try to get the IOC container to build that class. And so that's how I do the binding to my view from the view model. It's a fairly standard approach for doing MVVM applications. Does anybody have any questions on that? Is that too much? Are you guys familiar with that kind of service locator pattern for MVVM applications? Yes? No? Good. Questions? What you said you have a thumbs down. What? What's that?
Doesn't sound familiar.
Okay. Do you understand the approach, or do you want me to go into a little more detail? What's that?
More details.
Okay. So basically, so the idea is all these types. You know, I have an iWeb client that might be an online web client, but let's say I am doing this demo without Wi-Fi. I also have this web client class defined as a I have an online one, so this implements an iWeb client interface. And I also have an offline version of this as well. So this one, it kind of fakes out the data, simulates a call to a web service. So depending on what I want to do, I can set my bindings here, and the IOC container will build those. It knows how to build those objects based on all the dependencies I break up. So once I define all that, I can ask for an instance of the class down here when I do my binding in my view, and it'll do all the rigging up for me. Does that help a little bit? I don't want to spend too much time on it because it's more of a WPF Silverlight thing, but it's good to have a basic understanding. So anyway, that's how I can use static resources. I can also, I have a over here in the app XAML, I've defined a visibility converter, and you can also do this all in F#. So bool to visibility converters, that's something you come across in WPF and Silverlight programming quite a bit, because all the controls want a visibility, and a lot of times under view model you'll have a bool, so you can define these in F# as well and just use them. So I defined a simple bool to visibility converter, and basically we don't have to get into code too much, but it takes the input and switches it to see if it's true, it's going to make it visible. If it's false, it's going to make it collapse. So this thing, if you look at the signature, where is it? Well, the signature, it's using objects, but basically it's going to take in a bool and output a visibility. So the point here is not so much the code, it's just that you can do it. You can use visibility converters all in F#. And then lastly, at the application level, in my main window, you'll see I have so I have a list box defined down here, and this list box is what's displaying all these games. And so for the list box, I have a data template defined up here that uses a user control in this game item user control, which is defined in this XAML file. And that's the kind of template for each individual item. So you can use user controls just like in C#, but it's a little bit more of a workaround because F# doesn't support partial classes, so you have to do some hacking to get code behind if you want code behind. So that's one of the reasons that I kind of prefer the polyglot approach. There's other people that do all F#, and I don't know if you guys know Cameron from Twitter, but he's like he does the all F# approach and he really likes it. For me, it's not worth the hassle just to have F# in your views, but you can structure your applications the same way, and for WPF and Silverlight MVVM applications, it works pretty well to kind of structure your applications in a similar manner to how you do if you were, writing it in C#. So at a high level, this thing looks a little bit like a more object-oriented C# structure, but as we dig down deeper, that's where you'll start to see the benefits of F#. So now that we know how the application's kind of structured at a high level, the next question is, why would we want to use F# for this? Why not just C#? And so there's actually a lot of reasons, and I think in MVVM settings in particular, it's really cool to show off some of the strengths of F#. The way it reduces ceremony from your code, and some of the other techniques we can, you know, they're familiar with in F#, like asynchronous workflows and stuff like that, really shine for these kinds of applications. And so I'll go into a little bit more detail for the rest of the talk about this. What does F# do well? Okay. So backing up, I talked a little bit about the how the bindings happen between the view and the view model. And so now I'll show those view models and what they look like. So if I take a look at the game row view model, and this is the view model for each of the individual items in that list box. So this is each individual game. I've defined a real basic game model for this. So it's just a basic record type with a name, platform, box art, genre, and score. So a very simple model defined in F#, and the rest of these are just for doing design time, messing around stuff in design time. Just kind of some stubs to create an empty one, a dummy one, one with no optional members. So these are just some constructors or values, placeholder kind of values for doing design work. But really simple model. And I mean, if you've done anything with F# or you've seen other F# talks, I mean, this is a good example of how F#, really record types really reduce the ceremony of your code. But view models in particular, I think they even go further. So a lot of times in view models, you have this problem. So score, if we go back to the game class, score is a option type. And when we do the binding, you'll notice in the main window, there's that little star control. What we want to have happen is if there's no score, it shouldn't have star control shown at all. But if the score is 0, we want it to be 0. So the problem is if the way the binding works out is if you just bind directly to it as an option type, WPF will evaluate the binding to get the value of it first. And so it'll say, like, okay, what's the value of this? How many stars does it get? And of course that causes an exception if it's none, if there's no value for it. And so what's going to happen is it's going to throw an exception on there, and then when it goes to execute your visibility binding, which says, should I show this thing or not? That won't execute because of the exception. And so you'll get a control that is just, I don't think I have one up here, but yeah, basically you'll get just empty stars, which is not what you want because it looks like it got a 0 rating when in reality it just didn't have a score. So that's where view model comes in. You have some logic that you'll want to test in, that you want to add in the view model. And you'll want to be able to test this logic as well. That's the whole point of MVVM, is having this separate logic that you can test. So down here, let me see if I can okay, I'll work that for you. So you'll see that basically it's really simple logic, just matching the score. So I'm creating two properties now. One that's saying, okay, if it has a score, then you can do the visibility binding to this one. And there's another one that actually hits the score. So we separated those two components of the model out into two separate parts of the view model so that our bindings will work in our view. So we're adding some very, very simple view logic right here. But a lot of times you'll run into this kind of predicament when you're doing MVVM apps where you're like, well, my model kind of looks like my view model, but I should really add the logic to my view model layer. And so in C# a lot of times you run this thing that's like, man, it's going to be such a pain in the butt because now I have to create all these members and bind them just to the things on the model. But in F#, it's really not that bad. You have you're literally saying, like, okay, I want a new property of my view model that's kind of a placeholder for the box art, and just pass it off to the model for all these ones. And for the places where you want to add logic, you add the logic. What's even cooler about this is because of type inference, if something changes in your model, you don't have to go back and correct the type signature of the view model. So when I was doing this application, building this, I thought that I think platform was always going to be there in my model. Let me take a look it was either platform or it was genre. I thought games were always going to have a genre for my REST feed. So I made it a string type, and then I had to change it to option string. And I was like, oh crap, I got to go back to my view model and change it. And then I realized you don't have to do that in F# because it just inferred the type for you. So because of the type inference, it just picked it up. So if you're familiar with F#, you know that all these things are still statically typed. So you still have this coming back as a string option. Platform still comes back as a string, and so on and so forth for all of these members. They're still passing off the static types from the model, but you're just literally saying the type is the same thing as this one in the model. So you're reducing the clutter from your code quite a bit. Yeah, you had a question?
Yeah. How are you implementing the iNotification?
This doesn't do iNotify property change. I'll show you an example. Okay. We're going to do that next on the next view model. So this one is more to show the reduced ceremony of the code that you have, because this is the F# version of it. Now I did C# pseudocode of the same thing, and you can see it's quite a bit longer. I mean, it's like more than double the size of it. It's quite a big change. And while a lot of it's noise like brackets, you still have things like constructors that you didn't have in the F# one, and all the type annotations. So even the stuff you might say like, well, squiggly brackets are just they're white noise. You kind of filter them out, but you can't put this all in one page in your editor. This you can see everything in one screen. And even the significant characters in C#, the type annotations and other things, it's still clutter. You still have to say, well, is this thing a string? And like if you change your model, it needs to change in the view model. So the F# version of this, I think, is much more clean and concise. So that's one major benefit of using F# in this kind of a setting, is the reduced ceremony of the code. The view models are very ceremonious, it kind of reminds me of Java. Like there's a lot of boilerplate code there.
And yeah, when something like this, I can't help but wonder if they could be auto-generated, or like somehow idle-generated at one time.
So yes, that there is. One of my coworkers commented on this and he said, like there's this thing called notify property weaver which does this at IL time. And so you can do that, and it'll, to answer the other question about notify property change, it'll rig up iNotify property change and stuff for you, and there's this other bit of logic. You can add a little bit of logic there. The problem is if it starts to get complicated, you're still going to need to have some code in your, you still need to generate some code at some point. Like if your view logic is more complicated than this, you'll want to have more complicated logic. And I'm not an expert on iNotify property weaver, but that's another approach. The point here is more, there's different ways you can do it, but F# really reduces the clutter here, and it reduces the clutter in other places too. So while there's other ways that you can do it for view models, this is just an example of why F# is powerful and cool.
There is no separate.
What's that?
No separate.
This is mutable. Yeah, it's an immutable. Are you going to bind this?
Yeah.
Well, from the rest column.
It'll bind for one-way binding. So there's
one way.
No, in other words, there's no point in implementing iNotify property change on it anyway, because you can't change. So for what properties are going to change? You're not going to notify them.
Right, but there is no separate, so there's only one-way binding, right? You don't.
Yeah.
Yes. Yeah. For this one,
absolutely,
it's an immutable structure because we're just pulling out the REST service. But in this next view model, things get a little bit more complicated. So the main window view model is where we actually do most of the interesting logic. That's where when you press the button to go to the REST service, it'll actually go out and make the web call and set the mutable list of the observable collection that actually generates all of the games. So in this case, in C# a lot of times it's pretty common to have like a view model base for helping out with notify property change and some other things like that. So this view model base, I actually think this is pretty cool. this view model base, it helps out with the notify property change. So that's one thing that it does. It's written in C#, and it actually uses C# dynamic to do some of the, it dynamically generates commands based on convention, and I'll show that in a little bit below. But basically, it gives me some helpers, but I didn't have to rewrite it because of F#'s interop. So I could just inherit from this viewModel base class, written it up in C#, using dynamic, and just pull it into my F# code seamlessly. And I didn't even really think twice about it when I was putting this demo together. It just kind of worked. So what I do up here, this is basically some setup code to generate design time data. So I'm creating, this is what you see in the design. There's a little stubbed out list of games. And so I'm creating some stuff, creating new observable collection. These are the more important properties. So games is the type of this guy. It's an observable collection. So this is what, games is what gets bound to by the list class. And so this one has a getter and a setter. So this one is mutable. And it's using the viewModel base class to do notify property change. So that's how I'm handling notify property change in this case, is using a viewModel base class to help out with that. I pass the name of the property that I want to be set, and the viewModel base handles it. And this is one common approach for doing it in C# applications. There's other approaches. I like this one, but again, you know, your mileage may vary on this. But the point here is more just you can do the interop with C# pretty seamlessly. Now the other cool thing is that if you've done a lot of MVVM applications, the command bindings can be kind of a pain in the butt. You have to have, a lot of people have magic for working around that. This particular viewModel base uses a convention-based approach. So if it finds a method called execute underscore, it's going to generate a command for that. So it's using dynamic to do this. I don't want to get into the details of exactly how that works because it doesn't really apply to the application or this pod. But basically, it finds this thing called execute get games and generates a command for it. So it'll look down at the properties of the class, generate a command dynamically for that. And so that's how I'm doing my command binding right there. So this thing is, when I press the button to go get a game, this is the binding that, this is the command that gets executed. So this, it's pretty straightforward. The only quirky part here is you just have to, because of the way that REST API, this particular REST API works, it's paginated, and the individual images for each game don't come through properly, so I have to do a little bit of workaround for that. So if you go into the, so this function, get games by platform, is the one that's doing most of the magic. So up here, I'm doing some setup. This is magic for connecting to my REST API, and I'll cover this stuff in a second. But basically, when you ask for a game by platform, like we do in the view model, it goes through and it's going to have to. It grabs the list of all of the games for the platform, and then for each one of the games in it, it has to go and do a separate call because of the way that REST API is structured. So in practical situations like this, your data is not always going to be clean, and so for each individual element, I do another pass, and that hits the actual game data because the image elements are not set up right. So this one calls out to this function to get another game, and that's what actually does this returns a record, the model, which is then wrapped up in a view model and passed to the observable collection, which is bound in the view. So that's a lot to digest there. Does anybody have questions on how that whole process works?
What's that one? Where'd you get XN from?
It's a I define it, I'm using link to XML, and so all this does is wraps it up in an X name. Yeah, I think I found this on either a blog or just.
It's string concatenation, or that's what you're doing? With
It's kind of wrapping. So the way linked XML works, it's designed for C#, which has implicit casts all over the place, and so it implicitly will convert a string to an X name, but in F# you don't have that implicit cast, so you have to wrap anything. So any call to, so this one is it's grabbing the element in the XML tree. It's saying grab the name element and grab the US element to get the, and then get the value of it to find the name. So if you're walking the XML, it's, you know, there's a game XML element, and then there's a name, and then a US, and then that one contains the value. So when you're calling link to XML, you have to kind of massage it for.
Yeah, I was confused by the syntax. It's like XN space name. So is that?
It's a function.
It's a function
Yes,
call.
it's a
Wow.
function.
Yeah.
Thanks.
Yeah, so it's a function call in here. It's, you know, call this xn function, and all that does is a wrapper for this function, which is the one that actually generates an x name from a string. And it also makes sure I get the namespace correct, so it helps out a little bit there. Any other questions on that? Okay, because we're going to dive into a couple other advantages of F#. So one of the cool things here is when I was processing the images in here, I ran into this structure that looked kind of like this. So this is what the XML hierarchy sort of looks like for this. Can everybody hear me in back with the silence and stuff going on? All right, so I have a game, images, box art, US, and this is the value I want. This is I think it's a URL that goes and fetches. That's where you go and grab the image from. So when I'm doing box art, I want to say, okay, if any of these things aren't present in the tree, so for example, if there's no images, because all these things might be optional, it's REST data, some of the games don't have images, it doesn't have box art, right? So one way to do this is using you have an XPath approach for doing this, and so that's kind of a common one. The link to XML doesn't really support the XPath way, so I'm going to show a functional way to do it. And so if you don't use this approach, you end up with something that kind of looks like this. This gnarly triangle logic. You know, if images is null, then if it's not null, then grab the box art. If that's not null, then get US. If that's not null, then create a new bitmap image from the resulting URI, and then return that result. And so it's pretty gnarly. It's this nasty triangle code. And some of you might have an idea of where I'm going with this. That's basically to use option types, or the nasty monad word here. So how many are you guys familiar with the option module a little bit? Yeah. Okay. Do you want me to explain bind and map? Yeah. All right. So the way this works, it's actually pretty neat. So the first thing I do is this function, to get the box art, it's going to take an X container, which is the root element, basically. And the first thing I need to do is take this element, and I'm going to try to get the images element out of that. And what this try get element does is it's basically a wrapper around the linked XML function element. And what element does is basically, if the element is there, this X name, if it's present, what it'll do is it'll return the element. If it's not, it'll return null. Null is common in C#, but option types are far more powerful in F#. So what I'm doing here is I'm just wrapping this thing and kind of lifting it up to become an option type. So instead of returning null or a value, it's actually returning option now. So it's wrapping this function to return option types. Does that make sense? Okay. So once I've done that, I can now use the functions in the option module, option.bind and option.map. And these functions are actually pretty sweet. So visually, the way option.bind works is you have some original value that's an option type. If it's sum, it applies a function to it and returns a new value. If there's nothing there, if the original value is none, it will just return none. So you can kind of chain these together so that if it's sum, it always keeps returning the next thing in the tree, the next operation to do. If it's none, it just always returns none. And so if step 1 is none, the final result is none. Step 2 is none, final result is none. If all of them are sum, it just it carries through and always returns the next element in the operation. So what we do here is use bind to say, okay, if we found the images element using this try get element call, then bind it to call the option bind function to get the box art element. If we found that one, we return the US element, which is exactly the workflow that we wanted when parsing this XML feed. And so eventually we go down and use option.map, which works almost identically to bind. The types are it's just a different type signature. So conceptually it's doing the exact same thing. So this one it's saying, okay, if you found the element, take that element and select the value off of it, map it to a value, and then finally map out the resulting bitmap image. It works a lot very similar to the seek module or link. It's the same concept being applied in a different way here. So does this make sense to everybody? I think that's really cool. I think that's pretty. When I was writing this, I was like, oh, this is a good application of what it's actually monads at work. So it's a good application of that I think makes sense to me in a way that a lot of the other kind of academic demos did not. And so this is applied to XML processing. And in order to do this in C#, you'd kind of end up with something pretty gnarly like this. You'd wind up with some structure very similar to that, or trying to call out and work around link to XML to use XPath or something like that. So this is a functional way to process XML elements.
Why did you use option builder?
The builder, the workflow syntax didn't look as nice for this when I tried it. I actually did. I switched it into the, actually used the workflow syntax, and it's better than this for sure. But I think the piping syntax looks a lot better in this case. But you're right. You could use the other syntax, and it would work. It's just you're basically, you'd say like you have to give all of these steps variable names. So you'd say like, you'd still end up saying let images equal try to get element images, let box art equals box art, and so on and so forth. So you end up passing that through. So I think it was cleaner because it's kind of passing them through with this syntax. But if you prefer the other syntax, it's the same principle at work. So no reason why you can't do that.
You can also try exit patterns. So you deconstruct whole thing in one shot, right?
Yeah, you might be able to do some further magic for that, but I didn't want to go way over, people's heads for the demo, just because a lot of this is for a C# audience, not as like functional black magic stuff. But you could definitely go crazy with it if you want. So there's further you can take it, but it's kind of analogous to the seek module and how you apply that to reduce this similar kind of triangular code for processing sequences. Any other questions on this portion of it? Okay, so the next thing I want to show is using asynchronous workflows. So if you remember when I first ran the application, it was kind of gnarly, you know, like you click the button and you wait for everything to respond. So if I'm going to switch this over to usually, or is it usually an hour or hour and a half, or?
I'd say an hour and a half is probably about.
Okay. Well, then we can generate this guy using the. I can code it out. Okay, so we saw how we can, when we ran this, it was slow. So what we want to do is we want to make it asynchronous. So we're not hanging the UI thread while it's doing. So we can stretch the UI, can update and do everything we want it to do. So if I go to my web game source here, the first thing I need to do is, so now instead of at the very lowest level, the thing that's going to become asynchronous is my get response method here. So instead of returning an actual X document, I'm going to want to do everything asynchronously. And that comes from this interface over here, which has the download string and the async download string. And that's just a wrapper around the standard web client. So this is just an interface I created around web client so that I could mock things out if I was offline. So there's two methods here. So what we're going to do is, instead of calling this guy async or synchronously, we're going to call it asynchronously. So now the signatures are different here. Okay. So now in this response, it's basically I have to go and correct everything. But since the lowest level changed, I have to go and bubble all the asynchronous things back up. But the important thing is it's not going to change the way the code actually looks or feels. So I'll just go ahead and fast forward. To the asynchronous version of this guy. Okay. So now this get response function, instead of returning synchronously, I added the async block here. And all it's going to do is, if you're familiar with asynchronous workflows, it's just going to change this thing into returning an async of the string web response now. So you'll see that instead of returning a regular X document, this type signature has changed to an async of X document. But the structure of the code didn't change. I added a let bang and a return. A let bang means basically, in an asynchronous workflow, do this thing asynchronously. So asynchronously, go and get the download string. And now return the result. And so we added a couple keywords around here to fit it into the asynchronous workflow, but the structure of the code didn't change for this method. And the same thing throughout the rest of these. So now the call for my individual getGame function looks very similar to the way it did before, but I am asynchronously getting a response to get the game based on the game URL. And the only other thing I'm changing is down here for the return. I have to wrap this guy in the return, add a little bit of extra extra stuff to this. The same thing for this get game IDs by platform function. I wrap it in an async block right here. So wrap it in async. And now instead of getting the response synchronously, let bang asynchronously get the response and return those developments. So now in my main window view model, where I call this thing, I have basically the same structure to it, but I wrap this whole thing in an async block again. Same structure of the code as it was before, and now I call this async that start the function. And what that's going to do is it's going to run all the asynchronous operations on the GUI thread, but it's going to run them asynchronously. So it's not going to hang the UI when all these web requests are being made. So if it's waiting on a result from the web service, it's not going to hang the UI, but it'll still run on the GUI thread so that I don't get those nasty errors about trying to update my observable collection on a background thread when you're working with WPF or Silverlight, and you also don't have to worry about race conditions because it's all running. It's not running in parallel; it's just running asynchronous. So it's this is very similar to Anders' PDC demo from I think it was last year with the Netflix where he demoed all the power of async in the upcoming C# releases. But this is in F# today. It's been in F# since release, and you can deploy code with it. So you'll see if I run the application now, and I click on one of the little bit more games. It should update. I wonder if we have internet. Is my Wi-Fi moving? Oh, so the UI is moving. Okay, there it goes. It's running slowly. I guess the Wi-Fi is pretty slow, but you'll see. I mean, you get the point of how it's it's asynchronously getting each one. The Wi-Fi must really be slow because that is crawling. When I've done this demo before, it's usually like hundreds, at a time. But anyway, it's going through and grabbing all of the Xbox 360 games and pulling them in here. Okay. So, are there any questions on how that asynchronous transformation happened? Do you want me to go over any of the basic stuff again? I can go in a little more detail if we need. I know it's kind of quick going through there. Yeah.
I got a question about the start immediate. Like, what other functions you can use for that? Like, you said that makes it start, do it in a UI thread, but it doesn't.
Yeah. So you can call start, which will run on a background thread or run on a thread pool. The async module has a bunch of other things. So if you have a bunch of different operations and you want to run in parallel, you can you can take a bunch of asyncs and then run them in parallel and get all the results back. There's options for using synchronization contexts and switching active threads. So there's, in the offline version of this, I think it's a little different. So I can show you a couple other ones that I use there. So in the offline web client, where's the offline web client? The normal web client down here just calls the web services, and these are built in. They come with .NET framework. But in the offline one, what I want to do is I'm going to read from a serialized. I'm going to deserialize a list that I saved on disk of games and read them back in, but I don't want them to read in instantaneously. I want to fake some sort of latency. So the way I do that is right in here. So this async download string function is the one that does this basically. I go in, and when I'm running asynchronously, when I'm running synchronously, I don't bother with this, but in the async version, I start up a child process. So I use this async.startChild and call this simulate work function. And this is to avoid, if I do a thread sleep on the UI thread to simulate the latency, it's going to cause the UI thread to hang, which is not what we want to happen. We want the UI thread to be active so that you can see the list, the observable collection grow. So I start this as a child asynchronous process. So it runs it without impacting my the rest of my normal asynchronous workflow. So I'm starting up a child one, and in my child process, I'm switching to a new thread. So I'm saying run on the background thread. And so this one won't hang the UI thread, but it's just going to kind of pretend like it's going off and making a web call or something like that.
Oh yeah. So like if it wasn't running the background, I mean the UI thread, you would have to do the dispatcher thing, right? Wrap it in dispatcher if it comes from the thread pool.
Yeah. So this gets around that problem because a lot of times if you're doing async code like that or working with other tasks, like especially before task parallel library, you'd have this nasty kind of code flow where you'd say like, okay, do this thing on the background thread, now wait for the result to come back to the UI thread, and then I can update everything on the UI thread, but you have to have the dispatcher to kind of coordinate everything or a synchronization context. And so this uses, with asynchronous workflows, it uses the synchronization context implicitly built in on the GUI thread, and it just works for you instead of having to do a lot of imperative code generation. So does that make sense? So yeah, so there's a bunch of different methods in here in that async module for doing asynchronous operations. So you're not limited to just running on the UI thread. You can run in the thread pool and do all sorts of other good stuff. Or you can actually choose to run it synchronously if you want. So if you're testing, for example, you can just take an async workflow and run that sucker synchronously too. And in fact, I do that in my tests, I think. So I have some integration tests around the data service. It'll actually go out to the web service and make calls. And I think, where is that? Oh, in the integration tests. So in the integration tests, I don't want to do asynchronous behavior. I want it to run synchronously. So it's basically some gnarly integration test will go and run this asynchronous big game call synchronously in the test so that I can make my asserts happen. If I just ran that asynchronously, then I'd have to restructure my test flow to do that. I really don't want to have to deal with that in my tests. So for testing, I want it to run synchronously so that I do want to hang until the web request completes, but in actual production code, I want to run it asynchronously. So one other thing I want to go over is cancellation. And in a C# model, even with the new C# features that kind of pull in the concepts from the F# one, cancellation is still pretty nasty. You have to pass in a cancellation token source and kind of thread it down a list of method calls until you get to the, and kind of pull it along the way. So in the C# model, you're threading this cancellation token all the way down, but in the F# model, you don't have to deal with that. So if we look at the main window view model here, I added the ability to make things cancelable. So if I'm making a web request, I can have to enable it in the UI. Okay, there we go. So I can hit that cancel button and we'll stop the operation. I don't know why it's running so sluggishly, but there you go. So it'll run 4 or 5, then hit cancel. So I sometimes, for something like this, you'll want to add cancellation support because it might take 2 hours to go and pull down a bunch of data. And so you want to add cancellation. And in the C# model, you still have to kind of change the way your code works. You have to add a cancellation token parameter to each method that you call. So, for example, in the main window view model, you'd have to, whenever you make the call to get games by platform or any of the other async calls, you have to pass, in addition to the actual parameters that are about the logic of it, the platform and the page number that you want to get to the paging of the data, you have to pass the cancellation token all the way down. But in the F# model, it doesn't work like that. It's a lot simpler. So I still create a cancellation token. So the major differences here to do it async or to add cancellation. I create a cancellation token source. And then I take that cancellation token source, and when I'm calling the execute get games, first I cancel any previously running operations because I don't want it to have 2 asynchronous operations running at once and try to update the same observable collection. So that would be bad. So I cancel any previously executed ones, and all that the cancel function does is it just calls cancel on the cancellation token source and updates the UI so that the cancel button is not shown anymore. So it updates this is loading property, which uses iNotify property change, just like we showed before. So that's bound to the part of the UI that does the cancel, that shows the cancel button. And so when it's loading, the cancel button pops up, and when it's not loading, the cancel button is hidden. And then the other logic in here, basically show it that it's loading, and then create a new cancellation token source. So restart the cancellation process, and then so you're reinitializing something that could be canceled in the future. So you're updating this mutable variable, which is kind of nasty, but it's part of the workflow from the task parallel library. It's the way .NET does cancellation. And so now the only thing that changes is I take this cancellation token source and I make sure to pass the token to the async.startImmediate function. So that's really the only change to my logic. None of the calls in here needed to be aware of the cancellation token parameter because it's handled in the asynchronous workflow. So if you look at the web game source, all of these functions look the same. You're not passing any additional parameters. And what's going to happen is on each call, every time you do this let bang to say do something asynchronously, it's going to check the cancellation token to see if it's been canceled. If it's been canceled, it'll stop the rest of the evaluation just based on the behavior of asynchronous workflow. So every time you get to a let bang or anything that's going to be run asynchronously, it'll check that cancellation token source implicitly, and if it's been canceled, if the operation's been canceled, it'll just stop the rest of the evaluation right there. And so in the C# model, you actually have to have logic in here that say if cancellation token source is canceled, stop your actively running operations and return something like that. But in the F# model, it's just handled by default. It's built into the nature of asynchronous workflows. Questions on that part of it?
So if you look at IL code, you will actually see the check generate. Wait.
Yeah, you could pull up, F#'s open source, so you could pull up the source and look at how it's implemented, and you'd see the check in the asynchronous workflow builder that checks to make sure if it's been canceled or not. And I think I'm not 100% sure, but I think you might be able to grab the cancellation token. I think there's a call in I don't know if anybody knows, in the async module.
There's actually a property that says the form cancellation token.
Yeah, it's like get the
You need
cancellation
to get it
token
inside of a
inside of the workflow.
Yeah.
Yeah, you can say like async dot. I have to look at the call.
It's only default, right? You can grab only default.
Well, you only, in other words, each run of an asynchronous workflow is only going to have one, should ideally only have one cancellation token associated with it. So,
Really, isn't it static?
what?
Isn't it static all the time?
What do you mean?
Default cancellation token, isn't it static number?
No, default cancellation token is giving you whatever the cancellation token is for the async workflow, isn't it?
The actual
Well, that's
method.
static
I'm gonna
number.
look online.
Yeah, I think that's how it works. We have to go through and double check, and we can do that. It looks like we'll probably have a little time to go play around with that stuff, or I can show other things.
So if you want to override the default behavior and disable cancellation in some situations, how do you?
If you want to ignore cancellation,
Just don't pass the cancellation token.
yeah,
In some instances, or those occasions, you want to disable cancellation.
you could probably start up another work asynchronous operation within your asynchronous workflow that would not be cancelable. So you could do an async dot. You could like start, like I showed before, you could start that child operation that would ignore the cancellation token rules. So you could kind of wrap it and say like don't pass the cancellation token when you start it. So you could do another async call that would start immediate. So build up that async block, pass it to start immediate. So it'd still run the UI thread, but that one you wouldn't pass the cancellation token.
Makes sense, but sounds obvious.
Yeah, but I kind of think that it would be,
Logically, when would you want to cancel
Yeah,
the outer workflow, but not cancel the inner? I guess the whole workflow not being cancelable.
Yeah.
What's a use case for canceling, not ignoring it in just a subset of the workflow?
I think it's because you don't want to cancel certain sections, like
If you have a
let-
section that you want to complete, and you want to work, you want a section of the code that you want to complete and then cancel.
Yeah, so
But it's not,
that
it's not
tab,
terminating.
But in other words, that's going to happen anyway, because what's going to happen with the cancellation is each time you hit a let bang or a do bang or whatever, when it hits the asynchronous part, what it's doing is it's going to execute that, and then everything that comes after it to the net is going to get into what's known as a continuation. And all the cancellation does is after it returns, instead of applying the continuation and continuing the workflow, it dumps out. So you would get that behavior automatically anyway.
yeah.
Basically, if you want to cancel pieces of the workflow, you have to have separate cancellation tokens, right? That's how you control it from outside if you really want to. So if you bind specific cancellation token to a specific workflow, you give it inside, it's composable, you can call it cancel pieces. Doesn't have much context.
Yeah, so I basically to sum things up, if you want to get nasty and avoid the default implicit behavior, you have tools to do that. But the implicit behavior works for most of the cases, whereas in the C# model, you have a lot more control over it, but or I would say a lot more control. You have to kind of work that control in by default. You have to be more imperative, whereas this is a lot more declarative. It's a lot more
much better.
more.
I'm just trying to figure out how flexible this is.
Yeah, I would say, I mean, for most of the cases I can think of, it should be able to do the same things that you can do in the other model. I mean, you can always, I mean, if you really want to get nasty with it and be very imperative, you don't have to use asynchronous workflows. You can still call into the task parallel library by hand and use all of the underpinnings in the same way that you can in C# or VB or any other language.
Primitives and
Yeah.
mutex.
Yeah, you can do whatever you want.
Why
So
would you,
if you want to be imperative, you can be imperative. And that's part of the flexibility and the multi-paradigm nature of F#. So I think that's pretty neat. That you have that flexibility if you need it. Okay, so we talked about cancellation. We talked about asynchronous workflows. That's most of what I normally have. I can dive into a little bit more of how the WPF side of things works with F# if there's interest there. I can show more in-depth code in other places you guys are interested. Is there anything in particular that you want to see about how the application is structured that wasn't clear the first time that you want to go into more detail on? Or?
You were saying that you're going to show C# plus F#, the combination of the VPF application?
Yeah, I could show, I think I have a dummy application with that approach that I could show. Yeah.
One thing I'm curious about is someone was saying, why don't you do this cool, crazy functional thing? We were like, oh, I don't want to overwhelm you guys, but maybe since it's the end.
Yeah, I don't know that we have time to
Okay.
just go in and build do like the full active pattern approach for that one. Maybe after we could do that and stay for those who are interested. Did you have something you want to see more of? Or?
I just want to see the get game call, this recursive call. But,
Yeah, that one was kind of. So we'll start there. I'll try to, and then I'll pull up an example of the polyglot approach, which I think I have. I don't have it for this one, but I think I have another.
Can you show the overall structure of the application? The structure of the code that you
For the polyglot approach, or for this one? Okay, yeah, I can do that. So first, we'll one at a time. We'll go back to the games, get games call. So that's on. You're talking about this one. So yeah, so the reason I need to do it, and I should have done a better job of explaining this. I'm running on 2 hours of sleep on the floor of the Atlanta airport. So forgive me if I'm a little out of it. I know my explanations haven't been quite as good as I would like. But so the reason that it has to be recursive, let's just start there, is I kind of mentioned at the beginning, is you have this paginated data, which comes from the REST service. So you have, I think the default, I don't remember what the default is, but we'll say like 10 games. You know, you get chunks of 10 games from the XML feed. And so that's the recursive part. You want to get 10, and get another 10, and get another 10, and get another 10, until you run out of games, you know, run out of pages, basically. So that's why that part's being run recursively, because it's getting the game IDs by platform for a particular page. So it's going to be getting page 1, 2, 3, 4, 5. And then for each page, because the REST data is kind of gnarly, I have to go and fetch each game individually. So that's actually probably why when I ran that, it took a while for the first call to come through, because it was trying to get the list of all the games to come back. So it has to go and get each page, and then for each game in the page, it takes the ID and grabs the individual game element, and that one contains the proper box art. That's actually the whole reason I didn't do it like that. If the REST feed was clean, so if this is like, it's kind of a real world situation where if everything worked ideally, you would just take the list of games and wrap those directly. So instead of get game IDs by platform, it would just be get games by platform, and it would still be paginated. So you might have a recursive operation, but you would you just wrap you get games back, and so you could directly pull those up. Does that make a little more sense there? Does that part?
I was going to explain the tail recursion optimization. Like, it's interesting in this case particularly because it returns a unit type, so there's no actual return, right? But normally something in this form potentially would be DCO, but I think this does work out as DCO because of the.
I'm pretty sure it is. When I did this, I had to go back and double check it a few
I had to think
times.
about it pretty hard. So.
Yeah, because this was actually, so I didn't, when I was demoing this, I was like, and it just works out nicely. I didn't even mention tail call optimization, because when I was trying to write this, I was like, oh crap, because of the way the actual calls work out, it actually was pretty difficult to get this right, because for each of the pages, you have to make a separate batch of asynchronous calls to go get the individual game elements. So you want those to happen asynchronously, and you want the whole thing to be cal call optimized as well. So the last thing that this does is call async.startImmediate. So it's not like this function, each pass through, it's not actually, it's calling, so it's starting with async start immediate, which then inside of the workflow is where the recursion actually happens. So it calls get games, where does that get called? Yeah, right here, which basically calls it with the next page. So the last thing that happens inside of the async operation is the get games call.
Actually, you can get here in base condition. You mutate in games, and actually you can mutate them from server.
But remember that it's not running in parallel, it's just running asynchronously. So it's all going to run in serial.
No, not serial. You start immediate, not synchronous functions, right?
Nope.
It just callback call on UI thread.
No, this is going to run, I didn't say async.run parallel, I said start immediate. So
Yeah.
what it's going to do is it's going to make so it'll go through, run this, start the asynchronous workflow.
On different thread, not UI thread.
On the UI thread.
No, it's schedule a callback on UI thread, not computation itself.
All of the start immediate right here, it runs on the currently, it says runs an asynchronous computation starting immediately on the current operating system thread. So if I was not running on the UI thread, when I did the, where is it? This .games.add, it would throw me an exception because I would be on a background thread. So this code would not work if it was not running on the UI thread. So because I'm start immediate, if I was not doing start immediate, if I was doing a start, you'd be totally right. But then I get an exception there, and it's still running in serial because it's waiting in the asynchronous operation. It pauses here, and then it does the. So when this asynchronous call returns, then it'll execute the rest of the continuation down here. So that's one of the really nice features about this style of programming is you can write it in the same way that you would have written it if you were thinking about it serially, because it's still running serially. It's just not hogging the UI thread for web calls. So does that part make sense there? It's once you start diving down deeper, it starts to make your head hurt more and more. But the nice thing is you don't have to dive down that deep if you don't want to. You can take it at face value and just, oh, why do this one async? Bang, async, you're done, return. So, yeah, I struggled when I put this together, how to explain this part of it. I determined I didn't want to go into it for most of the time, just because it's actually, this call, while it looks pretty straightforward, because of the recursion, the tail call is actually pretty nasty. The last thing it does here is call get games. It doesn't do anything else on that line. It's just it's incrementing the page and calling get games. So as far as I can tell, it is tail recursive, and I'm pretty sure I tried it at some point in the past to make sure when I was putting together the demo. But yeah, do you want to dive deeper into that, or?
Yeah, either way. It's an interesting example in either case. I thought pretty hard about it. I was thinking really shocked.
Yeah, I had to look at this a few times before I got it. You wanted to see more of the structure of the application. So, like this is the main function for it. So, I load up the app XAML. App XAML deserializes into an application, and then inside of the app XAML it has a startup URI, which causes it to run the main window. So that's what pops up main window. And in the main window, it gets its data context using that view model locator and the IOC container that I talked about at the beginning to do all the wiring. So that's how it resolves its view model. And then, so when this gets instantiated, it says, okay, IOC container, go grab me a view model for me. And then that gets populated. That sets the data context. And then the rest of it happens with interaction with the view model. So when you click a button, so when you click on the SNES button, for example. That executes this command binding. So it calls the getGames function with the parameter SNES, which goes directly on the main window view model, calling this function with the platform. And remember, all the magic wiring happens using the base class, using C# dynamic. So that's how that works. More detail there, or is that sufficient? Okay. Now let's see if I can pull up, if I have an example. I think I have a simple one of, if not, we can kind of build one. I don't remember exactly where I left this, so I think a lot of it might be pseudocode. Let's see what happens if I run. Yeah. So this is for an article that I'm writing on this topic. It's not quite, so that it's not, I'm kind of in a state of flux on it, but basically this is what it looks like at a high level. You have a C# application with a reference to well, all the WPF stuff and my core. So I don't know if you guys can read that back there, but basically it's a reference to my F# core application up there, and the core application contains the all the view model and model code. So this is it's similar to the game model that I showed with this logic, but it's all the models and view models live here, and then you can do the same binding. So I don't have the IOC container for this, but I could do it the same way in the app XAML, where I have IOC container and use a view model locator to pull it up in the XAML. And basically, this is just taking the place of that app XAML and main window XAML that was on the F# side. So the difference here is that you don't have to do that hack that I showed at the beginning for getting the designer to work. You get code behind. So in the F# ones, you don't have that XAML CS or FS file. You have to rig that up yourself. And the designer kind of plays a little bit more nicely with it. It's just, the tools are designed for it, and I think it's the recommended approach for designing it from the F# team. At least the publicly acknowledged one from the F# team is use C# and VB for what they're good at, which is the awesome tooling support that comes around them. And I would actually agree with that in this case. It works in F#, you saw the full application, but I don't think it scales as well. I know there's some folks in the F# community that disagree a little bit and like to do it that way. But to me, it's a little nicer to do it the way it was designed to be. The tools were designed to work with C#.
Plus another benefit, if you were going to put once for the actual executable, that's a lot easier to do in a C# project than to do in F#.
Yeah.
Externally edit the manifest and all that nonsense.
Yeah, there's a few things like that. Like, did I show the XAML loader class?
Yeah.
Yeah. So that thing is pretty gnarly. Like, it loads up the XAML file based on the parameter that you set to it, and it's just like, okay, that's some nonsense you don't have to go through with the Polygon approach like that. So, and really, if you're doing MVVM the right way, you should have pretty minimal logic inside of your views. So you're really not writing much C# code. You're just, like, maybe you're rigging up some events or something like that, like doing some initialization at the start of it, hooking into some functions on the view model, but really it should be pretty limited code. And the code that's there is view logic, which tends to be very imperative anyway. So I think actually C# is a pretty good fit for doing view logic like that. It's what, the language is very good at doing that. And F# is definitely capable of it, but I think its strength is more on the back end side where you can leverage things like asynchronous workflows and the type inference and everything else to do what F-sharp's good at, and you can use more of a functional approach in your model layer, use your view models as your bridging layer, and then have object-oriented code on the the overall in the large, as they say. So I think it's a pretty nice approach for structuring applications, and that's what I would recommend going forward.
Why do you need the reference to the F-sharp core in the independent?
You don't really, but I think it was because so in this, I was using when I was putting this together, I was writing the same, instead of doing pseudocode, I was doing the actual C# code, and so this is the same implementation of the F# view model that does the match on the option type, and so I need to call option module that is to do the wrapping. You don't necessarily need it, but I think in practice, it depends on, if you don't have any logic, you might end up having to pull it in because of, if you accidentally return something from your F# view model, you might, let's say you return an option type, which you might want to do, then you can pull it in and use the, this approach. So, it's not necessary in this case. It's there. Okay. Was there anything else that people wanted to see? Yeah.
I noticed in the other solution you had a separate test project. Do you find that working in this sort of model, because you're doing UI work in MVVM, that you don't get script files and the whole REPL involved as much?
Me personally, I don't find myself using the REPL that often when I program. If I'm doing test-driven development, which I am most of the time, I don't find myself using the the REPL to play around with things. It depends. When I'm doing programming in dynamic languages, I find myself using the REPL a lot more, just because I'm I can play around with. Or if I'm doing spikes, just exploratory coding, I find the REPL is really useful for that. If I'm trying to figure out, I think I did this when I was trying to figure out how the REST API worked and stuff like that. I would use the REPL to spike some data stuff out. But when I'm actually writing code, I find myself kind of skipping the REPL and using tests to drive it. And so if I need to play around with my domain, it's in the tests. And a lot of that is, there's kind of a barrier I find with the REPL and your project structure. So if you want to pull in references or other things like that, you have to stick that at the top of your script file. And it's not that hard, but whenever I'm I want to play around with that in the REPL, put that over there, oh crap, I have to add this reference, I have to add this reference, and then it's I could have just written a test and I would have done the same thing. So, it's personal preference at that point. That's just the way I do it. So, yeah. Alrighty, any other questions, comments, things you want to see, or are we ready to wrap up?
All right, hand for Chris.
So that's my contact info. Thanks for having me, guys. Sorry, I wish I was here on a little bit more of an active memory, sleeping kind of thing, but I made it, so that's the good part. So, and all the code is on my Bitbucket. So if you want to play around with that sample application or see how anything was done, go ahead and you can check it out there on my Bitbucket account. So thanks a lot. It was fun speaking to an actual F# crowd. People were asking questions about F# stuff. I was oh crap. I actually have to think about that. So that was cool.